forget about dusty old blueprints and, those static 3D models. There is a revolution happening right now, all around us, where our buildings, our bridges, and yeah, even our cities are getting a living, breathing digital copy. So let's get into what this incredible technology is all about.
All right, here's the game plan for this explainer. We're going to start with a revolution that's shaking up construction. Then we'll properly meet the digital twin. We'll look at how it goes from a basic blueprint to a living model and see how it sticks around for a building's entire life. After that, we'll zoom out to see how this leads to smarter cities. And finally, we'll take a peek at the future that's being built as we speak.
So let's kick things off where this tech is making some serious waves: the construction industry. We are right in the middle of a massive shift, leaving old, slow methods behind and stepping into a whole new era of smart, data-driven building. And this really nails the difference. I mean, for ages, construction was all about paper drawings, walking around a site to manually check things, which meant if there was a problem, you found out way too late. But now we have these incredible tools like Building Information Modeling, or BIM, plus AI and the Internet of Things, all working together to create these intelligent systems that make the next big step possible.
Which brings us to the star of the show, the digital twin. And I really want you to understand, this is so much more than just a fancy 3D model you can spin around on a screen. It's a huge leap forward.
Here it is, the official definition. A digital twin is a virtual replica that is continuously updated with real-time data. That's the magic right there. It acts as a live, dynamic bridge between the real world and the digital one. I love this way of thinking about it. It's not a static picture. It's a living copy connected by an invisible nerve system. It literally feels what the real building feels: a change in temperature, a subtle vibration, a spike in energy use, and it feels it the very second it happens. So how does this nerve system work? It's all about this constant two-way feedback loop. See, sensors in the real building gather data. That data instantly updates the digital twin. Then, we can run simulations on the twin to test out different ideas. And those results tell us what to do back on the physical building. It's this beautiful, continuous cycle of learning and improving. Okay, that all sounds amazing in theory, right? But how do you actually create one of these incredibly complex models? Well, it doesn't just appear out of nowhere. It's built piece by piece, starting from that initial design.
So the whole thing kicks off with a BIM model. Think of this as the super detailed digital blueprint. It has all the core data: what materials are used, the exact dimensions, everything. Then, as the real building goes up, all these tiny Internet of Things sensors are embedded into its bones. These sensors are the nerves that start sending that live data back, breathing life into the digital model. And what kind of data are we talking about here? Well, a whole lot. It's monitoring everything from the basics, like temperature and energy consumption, to things like air quality, and even incredibly subtle structural movements and vibrations. All of this information, flowing in constantly, paints this incredibly rich, real-time picture of the building's health. Now, this is where it gets really, really powerful. A digital twin isn't some tool you use for a few months during construction and then forget about. No, it's a partner for the building's entire life. You can really think about a building's life in three main chapters: the design phase, before a single shovel hits the dirt; the construction phase, while it's being built; and the operation phase, which is, the rest of its life. And the digital twin is incredibly valuable in every single one of these stages. During the design phase, it's basically a crystal ball. You can simulate and test all kinds of different design choices. You can see how the structure will hold up in a storm, what its environmental footprint will be, and the best part, you can find and fix really expensive mistakes before you've even laid a single brick. That's a game changer. Okay, so construction begins. Now the twin becomes this live, transparent dashboard for the entire project. You can see progress happening in real time. It can automatically flag potential problems, like, hey, the plumbing pipes you're about to install are going to run right through the main electrical conduit. It helps everyone on site work smarter, not harder. But honestly, the longest and most important phase is when people are actually using the building. And this is where the twin is an absolute superstar. By monitoring everything 24/7, it enables something called predictive maintenance. That means it can spot a tiny issue with the HVAC system and say, you need to fix this now, before it breaks down completely in the middle of a heat wave. This saves a ton of money and can seriously extend the building's lifespan.
Let's make this concrete with a great example: a hospital. Imagine the energy bill suddenly spikes.
In the old days, a maintenance team would have to run around for hours or even days trying to find the problem. With a digital twin, it can instantly analyze the data patterns, pinpoint the exact piece of equipment that's malfunctioning, and even simulate the best, cheapest way to fix it. It's just smarter, faster, and way less wasteful. So we've seen how amazing this is for a single building, but what happens when we start connecting them? This is where we get to zoom out and see the really big picture. So let's just quickly recap the superpowers here. We've got real-time control, we can catch problems early, we can improve safety through prediction, we boost efficiency, we make smarter decisions based on actual data, and we can even lower our environmental impact. These are the crucial building blocks for something even bigger. Because when you start networking these digital twins, the twin of a building, with the twin of a traffic grid, with the twin of the power grid, you create a digital ecosystem for an entire smart city. Suddenly, you can manage traffic flows on the fly, optimize energy use across thousands of buildings, and dramatically improve how first responders react to an emergency. This all points to this really fascinating future that's literally being built around us right now. But, like with any seriously powerful technology, it's not all smooth sailing. There's incredible promise, but there are also some very real challenges. On the one hand, the promise is, well, it's mind-blowing. We're talking about systems that can learn on their own, make autonomous decisions, and find insights that no human ever could. But let's be real, getting there isn't a walk in the park. The costs to implement this stuff are high, getting all the different data sources to talk to each other is a huge headache, and of course, the cybersecurity risks are massive. And all of this leaves us with one last big question to chew on. We've talked a lot about buildings and cities, but this tech won't stop there. As our physical and digital worlds keep getting closer and closer, you have to wonder, what else is going to get a digital twin? A jet engine? An entire rainforest? Your own heart? The possibilities are just endless.